First of all, thank you all for being here. I know that the water looks really refreshing right now, and it's the afternoon, so I'm not going to hold you guys very long. I'm Agile retired Navy IT chief and currently solution architect with the Navy team, particularly with the NIWC team. So as we go through this right now, this software X concept that I'm going to go over, really the presentation and the talk track is really geared towards CANES. But as you're going to see, there's a lot of systems that you all are very familiar with, Navy, Air Force, doesn't matter, where you have software baselines and hardware baselines that are tied together. And that makes it very difficult to innovate, to upgrade, to do a lot of things. And so that's what this is really going to be geared towards. So as you guys see this, and you see CANES up there, really just think about any systems and any platforms that you guys have that are in that kind of situation that something like this would definitely happen. So what is software X, right? So this is what it is essentially. We are decoupling the software platform from the hardware. And the way we're going to do that is by using OpenShift. And so this isn't some radical new technology. This is what is radical about it is the way it's implemented and the thought process behind it. Now, the Navy, again, picking up the Navy, being a Navy chief, that's the one I'm most familiar with. They do have a lot of systems that are more out. Like I said, the software baseline and the hardware baseline are just tied together. So if they're trying to upgrade to new software, well, now you got to do the baseline for both, and that can take sometimes years from what we've seen. I'm sure you all are familiar with systems out there that have software running on it that is severely outdated, and there's no way, the path forward to actually upgrade that and to get that more modernized is years away sometimes. And so that's what we're looking to address here. Any systems that come to mind besides CANES? There's a lot of them. All right, just keep it in mind as we go through. All right, so the two things that I'm going to answer with this presentation is how does CANES leverage industry-accepted architectures and methodologies to quickly deliver new capabilities and to be resilient to self-moving platforms, and also how does CANES innovate on a flat budget? That's really important, the flat budget portion. I'm going to cover that as we go through. So first of all, what is CANES Software X? So it's essentially a modularized OpenShift. And so you see right here is, again, it's very general up there. You see that each CANES module is a discrete hardware software stack, and it's capable of running independently or part of a larger resilient network. And then also modules can be added to increase computer storage or both, and so you have a lot of flexibility there. Now, what you guys are seeing up there, again, is very general, but essentially you have your hardware stack, and that can be existing hardware already on board, or the new modules that we actually have working with other vendors. You have your Core OS, which is your immutable operating system that OpenShift runs on top of. You got the Kubernetes layer, and then on top of Kubernetes, you got OpenShift, which brings all the OpenShift goodness. And then after that, you have the operator framework, which is operators that are built into OpenShift that add further tooling and capabilities. And then on top of that, that's where you have containers and virtual machines running at the same time concurrently. Now, when you have OpenShift and you are running virtual machines, those virtual machines run as containers. So in the end, it's all containers, which is really good because, you know, as we all know, Executive Order 14028, everybody has to have DevSecOps, secure software supply chain. That can only be done with containers. And at this point, now you got that covered with us. Questions as we go through? Okay. So this goes a little more in depth into it. So again, it's modular, it's scalable, it's resilient, it's self-healing, and I'm going to cover that as we go through. That way I can just have some pictures and really talk to it. But yeah, so modules can be added. Again, it's all modular, right? Now the second paragraph up there where it says the design uses GitOps and the upcoming advanced delivery pipeline to sustain or quote unquote sailor-proof. I hate that word, but sailor-proof the platform layer. And so there's a lot that's going to be done. Now what that means is that once the software baseline has been set, so you have OpenShift, it goes to a Navy lab, that could be the Forge or wherever it is that's being done. And once they actually decide on the actual software layer and the platform baseline, then that baseline can be then pushed out to the fleet, and now you have every platform that's on the same baseline. If you're familiar with IT systems and networks on ships, those baselines can sometimes really vary tremendously depending on the platform. So this would allow one sensor to actually decide on that baseline, and that baseline now stays consistent across all the other platforms. It doesn't just stay that way. You can actually, you'll see the update system the way they're supposed to work. So, again, just the logical architecture is just really more advanced. Now, this is what's really key to this. So, OpenShift Plus, which is OpenShift with, again, plus, we're not the most mandated bunch when it comes to making things. So, OpenShift Plus, it comes with some extras, right? One of those extras is Advanced Cluster Manager. And so that's, again, we're not the most creative, it's a manager of clusters. And so once this is up and running, now that can be loaded with those baselines. And once you have those baselines in place, now you can actually bring in OpenShift clusters, again, modular. You can modularize them. It's just a simple box. Bring it in, put it on the network. The Advanced Cluster Manager will detect it. You can pick which baseline you want to add to it, and it'll deploy it, and then boom, like you just added more compute, storage, capability, whatever it is that you want. And it really depends on, like, the growth is up to you, whatever you got available and whatever power is available. So it's really, really nice. Modules are hot swappable. So if you have any hardware that goes into life, you can go ahead and swap it out, add some new ones. So it's really, really simple. Really, really simple to not just implement, but also to maintain. That's also really important down at the bottom. So without ever needing to shut down the network, you can go ahead and increase your actual compute power and add these different nodes. So yeah, I mean, we're warfighters, right? When we're out there especially for ships, submarines, anything like that, you can't just shut down the network whenever you want to make an upgrade or you want to add more storage, you want to add more capabilities. You don't have to. You just bring in a node, plug it in, it gets loaded up, and boom, you're just up and running, just like that. So this is really oversimplified, of course, but essentially this is kind of what it would look like. So you would have your different CANE modules, or your different OpenShift modules essentially, and those run concurrently, and those connect to the router, and as long as your router system is connected and has them all connected, then they'll all be managed by that Advanced Cluster Manager. So what this does is allows you to put modules, again, these modules are just boxes. You can put them throughout, let's say a ship, right? You can put them throughout your whole ship. So you can have true port, starboard, forward and aft actual coverage when it comes to those. So if you're in a battle mode and the ship gets hit, you know, whatever side it gets hit on, it doesn't matter. You're not going to lose your capability as far as your network is concerned because it's going to be survived. It's going to survive. So the Advanced Cluster Manager is going to detect when something goes down. It'll let you know, and then you can decide from there how you want it to fix it. And it'll actually shift loads on the go. So if you have a cluster that goes down, it'll switch those loads over to one that's more available, and you can decide which one it does it. You can do it automatically too. So there's a lot of flexibility with that concern. Questions? It could be both, but we prefer it to be physical, but it could be both.
Have you had any challenges that? Because we recently had challenge with the ship, plenty nice and physical. In terms of their work or
I'm not entirely sure that I've seen that, but we can definitely talk about it afterwards, and we'll see if we can find some use cases for you. Not a problem. Yeah, so this is what it is. Again, it's very simple, and what does this do, right? So let's go down here. So this is really key right here. The reason for that is you'll see that we have that hardware stack 1.2, and then we have a CANE module right next to it. So let's say Navy ship needs to upgrade now, we need this new software with this new capabilities. Well, guess what? You don't have to wait for the ship to get complete overhaul of its hardware. The existing hardware right now, as long as it has 8 cores, 32 gigs of RAM, and 120 gigs of space, you can install OpenShift Plus and have the Advanced Cluster Manager up and running. And then from there, you just add modules. What do you need? What do you want to do? Just add modules, spin them up, boom, they're up and running. Very simple. Not a crazy concept, but it's nice. It adds so much speed and capability. And so, the optimized CANE software lifecycle. So this is another really cool slide, right? And the reason for that is, so at the top, you know, you got regular today, you got your hardware stack, your software stack, and that's exactly how it gets put out. You know, development, and then you'll see the little red triangle, right? That's the deployment. So from there, that's where you actually get feedback from the ship. So you got development, you get your feedback from the ship, and then once you implement whatever changes needs to be done, you deploy it, and then it goes to in-service where you do your maintenance and upkeep. Whereas now, if we were to switch over to software X, right, you plan, you execute, deploy, scale, you know, you go through all this, but you'll notice the feedback. You can actually have feedback at every single stage. And so now you can really modify and make sure that whatever platform you're going to be launching is going to be really, really effective on whatever platform you're going to be running. Questions? All right, so that's it as far as actual software X. Now, speak more towards OpenShift and the sailors and everything that are out there. So we have a lot of things that are coming into play when it comes to disconnected environments especially. We do have a program right now called Project Mimir. And so what that is, it's a bootable container that you can just load using Podman on a laptop. So you can take that laptop over to whatever environment, a ship, be in the middle of the ocean, have no network connectivity or whatever. But that container, right now, it's about 7.5 gigs, and it gets updated every 2 weeks. That has every single instruction, knowledge article, Bugzilla, everything that Red Hat has. So it's the entire Red Hat database, essentially, all in a bootable container. It just a cool little GUI, so it's really easy to navigate. And then now we're working on trying to implement a small chatbot with it, so they can actually talk to it just like ChatGPT. And it just uses that Red Hat database. So there's that. Also, as far as training is concerned, if you all, especially Navy, the Navy has an ELA. The Air Force doesn't have one, but there's other options available. Where for Navy, training is free. As long as the sailor has an @navy.mil address, they can get free Red Hat learning subscription. Yes, sir.
I've used that account the last couple of years. I got a Red Hat training subscription to learn sort of like basic and work my way up.
Yep.
You guys have a great online tool.
Yep. Yep. Thank you very much. Yeah. So a little background. So when I retired as a Navy chief, right, Navy, I did nothing but Microsoft. So servers, that's all I did. When I got hired by Red Hat, I let them know, like, hey, I don't know Linux. They were like, that's okay, we'll teach you. So they brought me on board. They gave me a learning subscription. And I went from zero Linux to Red Hat certified engineer in 12 months. That training is fantastic. Has built-in lab environments, and it's a full lab environment. It's an actual environment. So you go in there, you can play with it, you can break it, you just delete it, and launch it right back up. Super cool. So training's there, documentation is there, it's readily available when they're out at sea or wherever they may be. And again, so this software solution is just to make sure that if we need to modernize, and we need to modernize now, we can do so. We don't have to wait years for these hardware baselines to be done. The software baseline can be done pretty fast, especially with Red Hat services involved. I'm pretty sure we can get that up and running. We do have we are testing in a lab environment right now. That's still ongoing right now, but as soon as it is done, then we'll have a working project up and available for you guys to actually see.
Just a couple of side comments. So I'm Mariana's colleague. My name is Josh Mills. I'm an account executive, and I'm out of San Diego. I'm definitely involved in this project. So one of the ideas that we've been talking to Amcor 5.0 about, and also with the folks at NIWC LANT, is the idea of potentially getting this software prototype that's operating on that hardware 1.2 system off the Champlain onto a Navy ship. And one idea that's being kicked around is potentially taking advantage of Trident Warrior and putting a software prototype out there to really put us through its paces. It's still in discussion right now. We're still working it through. There's a bunch of different stakeholders, like I said. PM from PMW 160, we want to involve Compact Fleet in that. PMW 790 is part of the conversation, as well as the folks at NIWC LANT as well.
Yes, sir.
Yeah, so speaking of stakeholders, and I heard you mention the board, so are you guys talking to PEO, IWS 10, and integrated combat systems, and I assume that this would be hardware agnostic, so
Right.
as the hatchables are coming into play now, the modular design cabinets,
Yep.
shouldn't be a problem whatsoever, right?
Should not.
So that's absolutely the concept. So my NAVC teammates, I cover now more USC4I, Captain Land. I'm aware that they are talking to them about the capabilities of OpenShift Container Platform Plus. And then one of the main reasons we wanted to make sure that we got into this innovation showcase is make sure we're getting the word out. So we're not just keeping it as a secret in one small silo or big silo for that matter in the Navy. So we definitely need to continue to get the word out.
And speaking of the Forge, so I speak to the Forge directly. It's I've been talking to Bill Pedler and all those individuals over there. I met with the captain here a couple months ago, And so we are working together with them already, just getting them more involved with OpenShift. They're all about virtualization right now, so that's going to be great. But just to kind of go into OpenShift a little bit, this presentation is not about OpenShift itself, I guess, the capabilities. But yes, we run containers, we run virtual machines all together, but OpenShift is a modern development platform. So that means that it has developer tooling already built in, DevSecOps, that's already built in, secure software supply chain, that's built in. Security from start to finish, it's all already there. When it comes to sticking, we have a compliance operator that you just install it, you get the sticks directly from DISA, and it runs the playbooks, and boom, it won't get you 100%, but it'll get you about 98% of the way there. So it's all, there's so much capability already involved that we could really, I could be here for hours just talking about everything that it can do. But yeah, it's a pretty amazing platform.
And our thought is that as questions come up based on what we presented here today, we're absolutely open to the idea of going into a deeper dive conversation that really getting into the granularities about what's being architected. And then where we are in the prototype to give you up-to-date feedback on how that's tracking. That's it. So the main objective here is to make sure that we get the word out and see if we can like this initial interest as well.
So, thank you all. That's the end of my presentation. I have something for you all. So, can anybody tell me what is the name of the OpenShift actual node that controls everything? And I have a cool little like dry bag here for you all. That's a cool little red logo on the back. Who knows it? It's very simple.
I'll give you a hint. It's in the name. It's functional.
Yes.
As a matter of fact, Ariane was saying at the outset, our naming conventions are not very imaginative.
No, they're not. They're really not.
So,
Oh, it's close.
you're close. There's an ER in the word.
Controllers are closest. I'll take that. It's actually Advanced Cluster Manager. So remember, Advanced Cluster Manager, as long as that's there, then that controls everything else.
The other key part about ACM or Advanced Cluster Manager is
That's your bag.
I liken that to the mechanism that really makes the survivability that Ariane's talking about a reality. Because the thinking is it's just like in a regular situation when you're spinning up and spinning down containers, God forbid the ship takes a hit, it would be pretty much the same thing, so just another day with Advanced Cluster Manager.
And for the sailors, again, those software basements are already loaded onto that Advanced Cluster Manager. So it's just a regular web GUI. They go in there and with 3 clicks of a button, they just spun up a cluster and it's fully capable and ready. So, pretty simple. That's all I got for you all. Thank you all so much.
Thank you, everybody.
Thank you for taking the time. Y'all enjoy Hawaii.